Hello, I am Björn Schnabel.
And I am Hanna Kabisch.
And we here at Kerbaltec Solutions are working on This is Moddable.
We want to introduce you to the most innovative, the most graphically challenging, and the most refined gaming experience of 2023.
This is Moddable combines the most recent developments of map generation, entity management, internal reflection, and much, much more to bring to you a game that seeks a competitor.
Just imagine the role of leading your own tribe to survival and prosperity in a resourceful world full of enemies and wild animals.
Our game is running entirely in the console to be able to minimize dependencies on your computer and bring our experience to everyone in the world. It even runs on your local printer. Why use a monitor when you can use the entire Amazon rainforest?
Additionally, we implemented a way for you to include your own ideas. You can now create your own entities and add important mechanics, for example, or break the mechanics entirely. All this in the easy and friendly language C#.
So, let us show you around our development process. This is Hanna Kabisch. Hanna Kabisch is our lead map engineer. She's working hard here at creating the maps for the game. What exactly are you doing?
So I wanted every player to have a unique experience. So that's why I'm implementing a way to generate a new, seemingly random map each time they're starting the game. To do this, I created the generate new map function, which assigns different resources to each field of the grid according to a noise map. I'm using Perlin noise here, which is a type of gradient noise that's also used by Minecraft, by the way. That makes it possible to generate a noise map that still looks natural, so the distribution of the resources can imitate a real landscape. So, for example, high noise values would mean stone or mountains in our game, and low values would be interpreted as water. Perlin noise is a type of gradient noise, as I already said, and I'm using the accord.math library implementation of this noise here. This lets me adjust, for example, the amplitude of a noise function and, most importantly, the frequency. So high frequency, for example, would result in lots of small mountains and small lakes, or that are all really near each other, while low frequencies tend to create those wide structures that take up all of the map if you don't pay attention. So we kind of have to find a middle ground. In the end, the frequency kind of adjusts the whole scale of the landscape. What's also important to note is that the noise function in of itself doesn't have any random element at all, so the same x and y values will always result in the same noise value. That's why we have to introduce a random element to it on our own, which is, in my case, a seed. So I'm just generating a random integer that I'm adding to my coordinates, and that's why we are always going to see a different map when we start the game, because I'm just changing the chunk of the noise function we are looking at. By the way, the forests in our game use a different seed value than the rest of the landscape, because otherwise it would be part of the height map, which would look really strange because forests would only spawn around mountains, and we want to avoid that. So in the end, this is basically really simple to use and will prevent boredom from seeing the same map over and over again. Thanks, Björn.
Very nice, thank you.
Well, let's try the next bench. So, let's move on to Björn. Björn is our leading reflection designer. So Björn, what is it exactly that you're doing here?
Yeah, we are trying to make the user capable of augmenting the game in a way how they like. So therefore we have to have the situation where there are different files all containing all the information about the entities, what they can do, what their actions on each turn are, how they behave if other entities interact with them and how they interact with other entities. And we of course have to make the program capable of knowing what is in these files and which files exist. And for exactly this purpose, C# brings a function on library that is called system.reflection. And we use exactly this library to search within the entire code of the project for classes which have the name that is that we specify with a string. For example, we can say we want a new worker. The user would input system new worker, new entity worker, and so the game would search for a class that is called worker and would start to create that. So that's pretty simple, and this also ties in with the input system of the game. But of course we have to make sure to handle every case of exceptions that could be thrown in this case. For example, their entities could not be found. So we catch those exceptions here and we throw an error. This makes it easier for the user to fix the problem and also for the game in itself to continue running even though something went wrong a little bit. Yeah, and to save our entities, we create a dictionary in the main game. You can see somewhere here, yes. Dictionary, which contains a string that is that contains the name of the entity and the respective function properties of this entity, which are declared somewhere down here. Yeah, you can see we have an object and a type, and when later this entity is used, for example, in each turn, we iterate through all of the entities in the game, and if they have a function called step, which is executed every frame, we execute this function step automatically for each entity. And this is done by getting the method step and invoking it with the respective parameters. And we also use a similar process to get information about where the entities are on the map and how they should be drawn. So entities which should be drawn on the map have a boolean which is called draw, and if this is true, we get their position, their map character, so the character that represents them on the map, and the color in which they should be drawn, and we draw them in this position on the map. So, and this whole system closely ties in with the input system that we will show you later in the showcase. But first, I think we will look at the pathfinding algorithm.
Thank you, Björn.
On our entity design desk, Anna Karbisch is working on a new pathfinding algorithm. Would you like to tell us about what users can do with that?
So this is possibly the most challenging part of the project for me. My goal was for the player to be able to assign targets for each of the entities. That can be other entities or just fields of the map. And then the entity would have to find a path to this location on its own. Luckily, pathfinding is a known standard problem that already has many different solutions. I chose a simple version of the A* algorithm in this case. A* is a so-called best first search. So it means that it tries to find the path to the target that has the lowest cost. To use that, we need a weighted graph. And luckily, our map can be, we can really easily derive such a weighted graph from our map, as the resources already have kind of a weight in form of a factor that modifies the speed of the entities on those resources. So for example, water has a higher weight than grass because entities are slower in water. And this also makes it possible to mark certain resources as not walkable. Stone, for example, entities shouldn't be able to go through stone. Stone is kind of an obstacle, so they have to find a path around it. So how does it work? Well, A star maintains a tree of paths originating at the start node. It extends those paths one edge at a time and until it reaches the target node. It will always extend the path that has the lowest estimated cost to the target. This is calculated by summing up the cost, the weights from the nodes from the start node to the target node, so kind of the cost that's already there, plus the distance from the object to the target, which kind of is the lowest possible cost that it can have to the target. Because of this, A star will always find the cheapest path to the target, so like the first path that reaches the target is also the cheapest one. The problem with this algorithm is its space complexity, as all the generated nodes have to be stored in memory. And I personally also had the problem that I first implemented the algorithm by using recursion, which obviously resulted in a stack overflow each time the target was too far away. So I had to change it to only use for loops. But this also let me control the maximum number of iterations that A star takes, so I can like prevent it from taking up too much time when it can't find the target. And it will then return just the best path it has found up until this point. So now entities are able to find the way on their own and even follow other entities around, which makes up for some really annoying enemies.
That sounds very great.
Hey Björn! Björn is our user input designer. He works on making the user able to tell the game what he wants it to do.
Yes, I heard that you looked into the reflection system earlier. My department depends on that system because we use it to let the user do whatever they wanted within the bounds of the entities that they have added to their game. Normally, as you can see, the game runs in frames. So when the user wants to input commands, he first has to stop the game and open the input mode. This is done by an asynchronous input handler. It is started when the game starts and runs in a parallel thread. When the space key is pressed, as I do now, you can see the game pauses, the frame is static, and the input mode opens. And this asynchronous input handler also is responsible for making it possible for the user to pan and zoom the map while the game runs, so that he doesn't have to stop it every time he wants to change the view. Once the input mode is open, the player can input commands by first entering the name of the entity he wants to give the command to, followed by colon, and the command he wants to execute. Let us just create a new map. And if I wanted to give parameters to that command, I would put it in brackets after it. New map doesn't have commands. And if I press enter, the game will create a new map. And once we start the game again, you will see we have a completely new map. It seems like we have an infinite loop here. Anyways, So this is done by looking up. Let me just find the code. This is done by looking up the information about the property in the library that was created by the reflection management team, seeing if it can be created by the player or controlled by the player, and if that is true, we can run the methods accordingly, of course taking into account all the exceptions that could be thrown and giving out errors if there's anything that the player should know that is going wrong. Yeah, and basically this is what we here at the user input do. We can give you a quick preview of panning the map, so you can hold down the arrow piece and move around the map, and with plus and minus you can zoom in and out of the map. Right, thank you very much. So, the development process is going strong, and I'm super stoked to be able to get my hands on the final product.
And we can now finally tell you when you can do so too. On the
27th of July,
you will be able to get your hands on the most immaculate game this year.
And we're extremely interested to see what you will do with it. As you can see, the user interface is friendly and the modding capabilities are endless.
We will see you at the launch party.